So chi-square is when I have attribute and attribute. So my x variable is an attribute, my y variable is an attribute as well. So it's two grouping, right? Two categories that I'm looking. And if and the only thing that I have is the group of individuals or group of observations that are characterized in one group versus the number that are characterizing the other groups, right? So I have at least two categories for each one of the groups, right? And I'm taking a look at this kind of two by two matrix analysis. Okay. It is here. I have attribute x variables, attribute y variables. Let's say test the decision of taking spring break vacation to Myrtle Beach or a mountain, depend on being single or in a relationship. So think about the data, right? The data will be every observation. First column, you put Myrtle Beach or mountain. The second column, you're going to put single or relationship. So there's just grouping. There's just categorical variable that I have to take a look at that. And these are the steps: identify the level, identify the classifications that are going to look, collect the data. We're going to summarize what we call an observation table. We're going to summarize what we call an as expected frequency table. So these are the two tables that we need to fill out. Then we're going to compute the relative square differences. We're going to do this manually, and we're going to add together all the square differences and know how to calculate that and calculate and interpret the p-value. So this is one that we're going to do it by hand. This is one we're going to know how to calculate, okay? So yeah, be ready, get your brains ready to think about now. So let's take a look at this. Yeah, we have the example here, right? So let's say we have example in GSCOM. For the people that don't know, is in the past how we used to call operations and supply chain majors. Okay, we call that GSCOM. That's when I got here and started working at Darla Moore. Everybody was calling GSCOM, GSCOM, GSCOM. I didn't have any idea what a GSCOM is because that was something internally here, but the students thought it was something that everybody knows, and you can imagine, tons of misunderstanding of not understanding that happened. So a few years ago, we decided to change the name of the major to operations and supply chain, change the names of the center to operations and supply chain, but I've been forgetting to update this slide apparently in the last couple of years. So we have GSCOM placements, and we have if the students were placed or not. So two columns, two categories for each one of those attribute data here. If I am GSCOM or other, if I'm placed or not placed. And here we're just summing the quantities, right? The people that were placed and that are GSCOM, people are not placed in GSCOM, others placed, others not placed, right? So just putting the data here and putting the math here, the calculation, and you can put that on Excel as well to do this problem, okay? So these are the three tables that we need to do. We need to do these three tables and calculate the p-value at the end. So here's the first the first data that we have, okay, with the sum at the end. That's the one that we saw in the previous email. So you can copy this table. The other ones are all math from this one. So copy the same kind of table, but in this one here, we're going to have the expected value, right? So that's basically what we're comparing. We're comparing if the proportion of GSCOM is the same for place not placed if the proportion of others is the same for place not placed, right? So the expected value is what does that. You're multiplying 50, which is this, so you're trying to calculate this cell. You're multiplying 50 here by 396 here and divided by this total here. So this times this divided by this gives you this. Okay? This times this, okay, so here and here, this times this, divided by the 500 again, give you this. 450 times 396 divided by 500. So this times this divided by this, always divided by this, gives you the expected for others. And 450 times 104 divided by 500 will give you the 93.6. So this is the expected if there is nothing going on. There's no impact or difference between them. Okay? And that's the way you do this math to understand what is the non-impact going on. The chi-square table, you're going to take the 46 minus the 39, square that, or yeah, multiply by the same value, right? Squared. And divided by that 39. Okay? So that's how many times above the 39 that your actual is. Okay? Squared. So 46 minus 39 divided by 39 is going to be your chi-square for this cell. You do the same for this one as well. So it will be the 4 minus 10.4 squared divided by 10.4. You're going to get to 3.938. You sum all of these. You do the same for this one. So what is 0.115? That is 350 minus 356 squared divided by 356. And you can see that this number is very small because the others and in both of those expected and placed are very similar. Okay? Okay, so now we have all our sum and it's going to be 5.525. Okay? And then you have to use this. There's a standard table for the chi-test as well, but it's too complicated to look at. So we're going to use just the, so you know, I make your life less difficult sometimes. Just sometimes. Chi-squared dist, the function in Excel that we're going to use. What is this? The chi-square statistics, 5.525, comma 1, which is the degrees of freedom. Okay, so here are the degrees of freedom. What are the degrees of freedom? So there's number of classifications minus 1 times the number of the other classification times 1, minus 1, sorry. So the number of GSCOM, not GSCOM is only 2. 2 minus 1 is 1. The number of place, not place is only 2 different ones. Minus 1 equals 1. 1 times 1 equals 1. That was the easy part. If you do that, we're going to get us our p-value. Yay! Which is what we wanted at the beginning, right? So p-value lower than 0.05, we reject the null hypothesis, right? So if the p is low, the null must go. Remember that. I was trying to remember. When the p is low, the null must go. P is low? Yes. Only one p-value that we are testing. We don't need to divide anything. So threshold 0.05, the p is low, the null must go. So what can we say here? GSCOM students are placed in statistically significant higher proportion than non-GSCOM majors. There is a significance in terms of being a GSCOM and be placed or not placed. So here are some kind of examples just to see how the p-values and work. So here, let's say we have another example. Why is one significant and others are not? So let's look at these in one time and this in another time.